Okay. Hi, welcome. This is Motsi. It is my pleasure, and it will always be my pleasure to have you around. Today we are going to consider factorization. Of course, this will be part one to factorization. Part two is coming. Perhaps we may even have part three. But this will be the problems that are going to assist us as we explore this concept of factorization. A disclaimer. This video is not level specific. Whether you're deep in algebra or you're just starting out, you should equally benefit. However, if there is something specific that you want me to address, please let me know in the comment section. And if it is that urgent, I have a Preply account. I'll leave the link either in the comment section or in the description box. Otherwise, let's get started. The first question, we are asked to factorize 15x minus 5y. To factorize simply means you are representing a number as a product of its factors. For instance, if I give you 10 and I ask factorize 10, you can say 10 is equal to 2 times 5. This gives us 10. In other words, you have represented 10 as a product of its factors. Factors are things that get into 10 without leaving a remainder. Therefore, this expression, as much it is involving x and y's, you are required to find two factors that when they are multiplied, they can still give us this expression. Here is how you do it. First thing, you want to find the highest common factor of this term and this term. And from the look of things, the highest common factor of 15x and 5y is 5. And once you find that highest common factor, you go ahead and you open the brackets. Now, you are going to divide this, your highest common factor, into this term and into that term, and boom, you've factorized. What is 5 into 15x? Of course, this will be 3x. And 5 into negative 5y should just be a negative y. And they're factorized. You have this factor and this factor that when you multiply them, they can give us this. You can prove it for yourself. 5 times 3x gives us 15x, and 5 times negative y gives us negative 5y, which is the exact equivalent of what we started with. That's how you perform factorization. Let's go to the next question. We have 12ax squared minus 24ax minus 48a squared. And our assignment is the same. We're supposed to factorize that expression. In other words, you want to find two factors that when they are multiplied, they give us that expression. Similar to the first one, as much as it is 3 terms, but we'll do the same process. What is the highest common factor of this term, and this term? Let's begin with the numbers. Certainly it is 12, because 12 gets into 12, 12 gets into 24, and 12 also gets into 48. Then we'll do the same for the letters. So A can get into A, it can also get into this A, and it can also get into A squared. So 12A qualifies, Unfortunately, x cannot, because as much as it can get into this term, but it can't get into that term. It means that 12a is the highest common factor of all those three terms. Let's go ahead and divide 12a into that. You can see that will remain with x squared, and 12a into that, you see that will remain with negative 2x, and of course 12a into that will remain with negative 4a. And this is our term or our expression factorized. And if you want to prove, you can multiply this and that, and you can get this and that, you get that, this and that, and you get that. And this becomes our final answer. If you think you can give it a try, you can try question number 3. Otherwise, if you're not that confident, you can wait for me to do it with you. Okay, next question. With p m plus n minus q m plus n, and our assignment is still the same. We are to factorize this expression. Well, first thing first, what is the highest common factor of these two terms that I have in this expression? Unfortunately, unlike the first expression where I could clearly see that it's just a single term 5 that was the highest common factor, when I have an expression that looks like this, I have an expression, well, actually we have a term that is made of many terms that is going to be the highest common factor. From the look of this, it is actually m plus n that is actually a factor, and we're just going to take it as is, and m plus n is going to be our factor, and we're going to take it outside and we open our bracket. Let me slow down. This part is quite important, and we're going to use it in our next video. Therefore, I have to properly explain. We have this term and we have this term. Our assignment is to find the highest common factor, and what looks like is our common factor. In other words, what is common in these two is actually m plus n. Therefore, that is going to be our highest common factor. That's why I took it out, and when I was done, I then opened the bracket. That means it's possible that I can divide this into that, and of course I'll remain with p, and I'll divide this into that, of course I'll remain with q, and boom, I have factorized the expression. I'll just do it one more time because this part is important. If you've understood, you might go ahead and skip the video, but if you have not, let me just use one last method to help you understand. Let's just say m plus n is equal to maybe y. That means that wherever I see m plus n, I'm going to write y. That means I can write py minus qy. Why? Because m plus n, I've made it to be the same as y. And wherever I saw m plus n, I was using y as I have written it here. Therefore, I can easily factorize. What's the highest common factor? You can agree with me that the highest common factor is y. So I took y out as my highest common factor. And of course, y into this, I remain with p, and y into that, I should just have a q. But remember, what is y? Y is actually this. So instead of writing y, I'm going to take back this guy, which is m plus n, and of course I'll continue writing this as is. I hope I've done my best to try and explain how we can perform such kind of factorization on terms that looks like that. In our next video, we're going to factorize quadratic expressions, which this technique becomes quite handy if you are to fully understand what we're going to be doing. We're done with this series. Actually, we are done with this video of the series. If you have enjoyed, make sure you smash the like button, and if there is a friend you think they may enjoy or they may also benefit from this content, please do share the video with them. And if you want to be part of the community, make sure you smash the subscribe button. Otherwise, it's me, Motsi, who's always happy to be with you. Thank you.